take a moment and really read through the question very carefully. If you look at the second line, one of the things that I want to focus in on is it says that the temperature of the potato is 91 degrees at time 0. So that's an initial temperature. Okay, so that's at time 0, the temperature of the potato is 91 degrees. And the reason why I want to focus in on that is look at part A. Now, it does say write an equation for a line tangent. Think about what that means. When it asks you to write an equation for a tangent line, what's the thing that you should be thinking? And hopefully you're thinking y minus y1 equals m times x minus x1. All right, now, what values did they give you that you can plug in here right away? Well, they told you at t equals 0, the temperature, which would stand for H, right, is 91. So we can say y minus 91 equals m times x minus 0. I'm going to put the 0 there. You don't have to. I'll get rid of it in a minute. Okay, now, so the thing that we're looking for is the m, which is the slope. But let's think about what we have here. That is slope. So basically, all we're going to be doing is dh dt, and we're going to be evaluating that at time 0. Okay, so that's -1/4. 0, oops, I'm sorry. At time 0, h is 91, isn't it? Okay, so I'm going to put in 91, and that would be, what, minus 27. Okay, and then work that out. And that's going to end up being -16. So let's go back here, and we have y minus 91 equals -16x. I'm going to drop the 0. All right, now the second part of this question is asking us to use this equation. So here's part of our answer. Use that equation, and it wants us to approximate the internal temperature of the potato. Remember, temperature stands for H at time 3. So y is, we are approximating, so I'm going to put the approximate sign, -16 times 3, and I'm going to add that 91 over here. And remember, this is non-calculator, so no cheating, you guys. And you're going to plug that in, so that's going to be -48 plus 91. So then y is approximately 43 degrees Celsius. So use this equation to approximate the internal temperature of the potato at time 3. So this would be my H of 3. Okay, we have done this question, this type of question, but it's been a really long time, so I'll go through this one nice and slow. So they want you to use the second derivative to determine whether or not your answer in part A, that would be our tangent line, is an underestimate or an overestimate. Now maybe you don't understand the second part, but let's start just by taking the second derivative. Well, here's the first derivative, right? So we're going to take the derivative of that. So that would be d squared h over dt squared equals, and then what I'm going to do here is I'm going to do product rule. So I'm going to take the first times the derivative of the second. So that would be -1/4 times the derivative of the second, which is dh dt, right? Okay, plus the second, which is h minus 27, times the derivative of the first, which is 0. So that's going to disappear. All right, so let's go back and look here. So we have d squared h over dt squared, sorry, equals -1/4. Now, what I'm going to do is I know dh dt is equal to this, so I'm going to substitute that value in. So I'm going to make that -1/4 times h minus 27. Close those. And that is going to give me 1/16, right? times h minus 27. Now this says at time 3 though, doesn't it? So then I am going to take my d squared h dt squared and that is going to be evaluated when t equals 3. So that is going to be equal to 1 over 16. All right, now let's just take a minute here. If t is equal to 3, then what I'm really looking for is h when t is equal to 3. So go back to your answer from part A, and you'll see that your h of 3 was 43 degrees, right? So I'm going to put 43 degrees, whoops, thought I was on my pen there. I'm going to put 43 degrees in here. Okay, so let me just stop again. So I'm evaluating a t equals 3. So what I need is when t is 3, what is this value of h? And if you go back to your answer from part A, you should see that you wrote down that h of 3 is equal to 43. So that's why there's a 43 here. Okay, just to reiterate that because that's a little tricky. All right, and then the rest is just math. Okay, now listen, I'm not really concerned with what the number is. I just want to know what kind of number I have here. So if I work this out, I realize that I have a positive number. Now let's think about this for a second. So I have the second derivative when I plug in a 3 is a positive number. Second derivative is positive. Second derivative is positive. What does that tell you about the function? If the second derivative is positive, what does that tell you about the function? Doesn't that tell you that the function's concave up? Now, I'm just going to draw a picture anywhere, but I know that my function has to be concave up. Why? Again, because the second derivative is positive. So, if my function is concave up, now let's read the rest of this question. It says, use the second derivative to determine whether your answer in part A, remember that's your tangent line, is an underestimate or an overestimate. Now listen, guys, here's the graph of the function. We did a tangent line in part A, right? Where does that tangent line have to be? Doesn't it have to be like, maybe just watch my little cursor arrow here. It could go like this, or maybe it could go like this, or maybe it could go like, whoops, like that. But any way you slice it, isn't my tangent line underneath my curve? Okay, so I'm just going to draw one of the possibilities. So for example, perhaps that could be my tangent line. So read the question one last time. It says use your second derivative. So that's, we used our second derivative to determine that the function was concave up, right? To determine whether the answer in part A, in other words, is the tangent line. Now let's look at this. Is the tangent line an underestimate or an overestimate? Do you see, because this tangent line is under this curve, it's an underestimate. I'm going to repeat that again. So since the tangent line is underneath this curve, then that means your answer to part A is an underestimate. Okay, so again, this is what you would write then. It's an underestimate because the tangent line is under the curve of h. Okay, and then let me just reiterate here. This is the curve of h. Now, this is the answer, but I just want to show you, for example, let's just say in our second derivative here, what if we had gotten a negative number? So just to show you real quickly how that would work, if we had gotten a negative number, our picture for h would have been concave down. And then the only option for our tangent line would have had to have been like maybe somewhere here, or somewhere here, or somewhere here. And any way you draw that picture, you're going to see that your tangent, whoops, bad picture. You'll see though that your tangent line is on top of the curve. So therefore your tangent line would be an over approximation because the tangent line is above the curve. Okay, so those are the only two scenarios you're going to have. You don't need to worry about anything else. Alrighty, so I hope you've read this through, and it wants you to find an expression for g of t. And don't forget though, they did give you this. And then we'll go on to the last question that they also ask you. But let's find g of t first. So hopefully you realize this is separation of variables that we have to cross multiply. So if I cross multiply on one side, then I'm just going to get d of g is equal to negative, and then g minus 27, that quantity to the 2/3 power dt. Okay, now remember, I want to try to get these g's, since that's what I'm solving for, as much by themselves as we possibly can. So the only thing, I'm not going to bring that negative over. I'm just going to bring over that quantity to the 2/3 power, okay? So g minus 27 to the 2/3. So that will cross out here on the right. So then I'm going to be left with d of g over g minus 27, that quantity to the 2/3, equals, and then we've got negative dt. Okay, so remember at this point, what do we do next? So we integrate both sides. Okay, and then what do we do on that left-hand side? What is it called? U substitution. So my u is going to be g minus 27. And then my du is going to just be 1 dg, right? So I'm just going to write dg if that's good for you. Now, so that's going to give me the integral of du over u, which is just ln, right? So, oh, what am I talking about? That is not the integral of du over u. I forgot to the 2/3 power. So let's try that again. So that's going to be the integral of u to the negative 2/3 power du. Sorry about that. And then I'll just leave this for right now. I'm going to put the negative on the outside though, and dt. Okay, so then that's going to give me 3u to the 1/3 equals, and then over here, whoops, that's a dt. So that's going to be negative t plus c. And I'm going to plug that u back in, and that is going to give me 3 times g minus 27, that quantity to the 1/3 power, equals negative t plus c. Okay, so I started another slide just because I was running out of room. So if you go back though and you look, remember it did tell you that g of 0 was 91. So we can plug that in right now. So we know that g of 0 equals 91, right? So that's going to be 3 times 91 minus 27 to the 1/3. And then we really have 0 over here plus c, right? So I'm just going to write c. Okay, well, 91 minus 27, and that is going to be 64, right? So 64 to the 1/3 power. That's the cube root of 64, which is 4. So then I know that c is 12. Okay, so then let's go back. So I've got 3 times g minus 27 to the 1/3 power equals negative t plus 12. So I'm trying to get, now all I'm trying to do is just solve for g, right? Okay, so the first thing that I'm going to try to get rid of would be what? To multiply by 1/3, right? Because that will get rid of that 3. And I'm going to multiply this by 1/3 also. So those guys are gone. And I am going to have on the left-hand side g minus 27, that quantity to the 1/3 power. And then over on the right-hand side, I'm going to have negative 1/3 t plus 4. Okay, next thing I need to get rid of is that 1/3 power. So I'm going to multiply by a power of 3, which will cancel that guy out over there. And I'm getting closer. So I have g minus 27 equals negative 1/3 t plus 4, that quantity to the 3rd power. Don't worry about that. That doesn't matter. Okay, and lastly, we want my g of t. So g of t is equal to negative 1/3 t plus 4, that quantity to the 3rd power, plus 27. All right, so it says to find an expression for g of t. So we just did that. Yay. All right, let's see what else it asks. It says based on this model, so in other words, using that equation, what is the internal temperature of the potato at time 3? So it's easy enough. They just want g of 3. So we're going to do negative 1/3 times 3 plus 4, cube that value, plus 27. All right, so g of 3 is equal to, that will be negative 1 plus 4, right, which is 3 to the 3rd plus 27. Well, 3 to the 3rd is 27, isn't it? Plus another 27 would be 54 degrees Celsius. Done.